Cho, and today I'll be going through the uh, answers for the prelim exam 2025. Alright, let's start with paper 5 first, which is our practical. Then we'll move on to paper 4 and then finally to paper 1. So at any point of time, if you're unclear about something, right, just record it down on your paper, write it down with a green pen, and then you can ask the teacher who's present, right, or you can also wait until I'm back for my reservist and then we'll go through the answer. Right, don't worry, there's still time to make the edits. Okay, so just a few comments about your paper 5. I know that this may be your first like big prelim. Of course, it's the first time that you sit through both the combined component with the chemistry and the bio. But I would say that overall, my feeling is that the class is not very well prepared for the practical. I remember I gave you my practical notes already, right? And there are a lot of materials that we have, but I feel that some of us are still not really using the practical notes, still making the same mistakes that I told you not to make when we did all our practice practicals and all our trials, all right? So I'll point out during the paper. All right, let's go through now. Okay, so number one thing that mistake is not reading your paper. So when you get your paper, make sure that you really read it carefully. All right, there's a lot of hints given in the procedure, things that you should repeat, things that you should the hints lah that you cannot you must read it. Okay, so yeast is a microorganism that contains enzymes that can oxidize glucose. The moment you read this, right, you should already be thinking of the word aerobic respiration, right? You see the word oxidize, don't just say oxidize. What is oxidize? It means aerobic respiration. Okay, so you get two yeast solution, S1 and S2. They have been treated under different conditions. Okay, so you think logically to yourself, one of them probably will be at optimum temperature, right? And other one probably not at optimal temperature. Okay, so let me review to you first. Test tube S2, right, I boiled it, right? So I actually boiled it already. Then S1 is at room temperature lor. So that means S1 is the living yeast, S2 is the dead yeast. Okay, so you are required to use a bicarbonate indicator, and then this table will show you the color of the indicator under different concentrations of carbon dioxide, right? So under high concentration, yellow, atmospheric carbon dioxide, red, low concentration of carbon dioxide, purple. Okay, so by looking at these three colors, you really can sort of make a guess already lah, right? And when just now, like I said, some of you didn't read the question because if you're writing other colors other than these three colors, you're writing other things like pink lah, right, blue lah, which are very very strange colors which are not even given to you in the question. Okay, so all this procedure, right, you've already done it, so I won't go through too much. Let's talk about the answer here. So answer is that for test tube 1, within about 3 to 10 minutes, the solution will turn yellow. Okay, later I explain why. For test tube 2, as I already told you, right, it's already boiled yeast, it's dead yeast, so the solution will remain purple. Okay, why does it stay as purple? Because over here, you have that 1 drop of sodium hydroxide. The sodium hydroxide causes it to become a bit alkali, right, and then it will stay as purple, it will remain as purple. Okay, and also over here I gave you the instruction. I said after 15 minutes, record no visible change. Some of you did not read this instruction and you write your other way of writing. Okay, I try to give you some benefit of doubt if I can see that you clearly understand that there is no change, right? For example, you say remain purple, right? I think that is acceptable. Okay, but also a lot of you started writing funny numbers lah, right? So when you write the time, you can either write new or you can write 15 minutes. It's both fine. But some of you write strange things like 30 minutes, 40 minutes, or things that are not logical. All right. So at the spirit of everything, right? Remember that there's a human being that's marking your work. Right, so it's not AI that's marking your work. A human being is reading your work and trying to understand what you're writing. So try to, it's like a bit of a mental war, right? Mental challenge between you and the examiner. Examiner is trying to test your knowledge. You're trying to decipher what the examiner wants you to know. Okay, so the answer will be for test tube 1, 3 to 10 minutes, solution turns yellow, and then for test tube 2, you can write 15 minutes on new, and then the no visible change. Okay, explain why the test tube change color. Okay, so for test tube number 1, right, why they change color? So we know that yeast can do aerobic respiration. So when aerobic respiration happens, the glucose is broken down into carbon dioxide and energy. Right? and there will be a high concentration of carbon dioxide that will cause the bicarbonate indicator to change to a yellow color. So 1 mark for writing aerial respiration, 1 mark for giving the concept that when there's a high concentration of carbon dioxide, that will cause the bicarbonate indicator to turn yellow. Alright. Then suggest a possible explanation if a test tube did not change color after 15 minutes, which will be test tube 2. So there's a few reasons, right? I mean, the key reason, of course, is that the yeast cells are dead. Now, even if you don't know this information, right, there's a lot of hints that were given to you in the paper, right? And one thing that you actually will have noticed is the bubbling of the yeast. When you're given that fresh yeast, you will notice that one of the yeast will be bubbling, right? That bubbling indicates that there's producing some kind of gas. Even if you don't know anything, you'll see there's bubbles coming out, right? The other one is completely still. There's nothing, there's no movement, no bubbles or anything. So I think you should make that educated guess lah, right? And try to figure out what's going on. You can also say the yeast, the enzymes in the yeast were denatured, but please do not write enzymes are inactive, right? Inactive can only occur when the enzymes are in a very cold temperature. Then the enzymes will be inactive. Okay, so that's 1 mark. Now let's talk about this conducting an investigation on the effects of temperature on the rate of yeast respiration in yeast. I'm a bit disappointed in this because I already gave you this so-called formula, right, that you can use when you're talking about investigation, right, or writing a procedure. So remember these numbers: 5 independent variables, right, 2 to 3 constant variables, 1 dependent variable, and repeating 3 times to get the average or the mean. Okay, so if you sum it up as 5, 3, 1, 5. 5, 3, 1, 5. So whenever you see this kind of so-called writing a procedure, remember these numbers, right? 5 5 independent variables, right? 2 to 3 constant variables, 1 dependent variable, and repeat experiment 3 times to find the average mean, right? And then plot it on a graph. So with that, you will be able to cover the 4 key variables, right? Let's talk about what are the key variables here. So we start by creating a series of yeast and glucose solutions in a range of water bath with different temperatures such as 10 degree, 20 degree, 30, 40, 50 degree using a thermostatic bath. Okay, so I want to re-emphasize, it is not enough to simply create a range of different temperatures with then you forgot to write the exact temperature. Okay, so that's mistake number 1, not writing the exact temperatures that you want. Okay, so you think of it like this: you are creating a recipe for baking a cake. Would you like it if someone tells you, go and bake a cake at some kind of temperature lah? Right? Then you'll be like very confused. What kind of cake do you want me to bake? What kind of temperature do you want to use? So always give that kind of detail in your answer. So you need that 5 temperature, right? And how do you get the temperature? You cannot just assume that the examiner knows how to do this procedure. So there are 2 ways you can do it. Of course, one is you use ice. You put ice and you mix with hot water, but that's a very inefficient way of doing things, right? A very long-winded way of writing also. So to make things short, you just say use a thermostatic bath. What is a thermostatic bath? It's basically just a heater lah, right? The heater system that will keep the water warm for you. It's just called thermostatic bath. Okay, number 2, we want to talk about some constant variables, right? Depending on the question, you can write between 2 to 3 constant variables. So you say the concentration and the volume of the glucose and the fresh yeast solution should be kept constant. Okay, if you have some hints about what volume, you can even write it down, right? Say for example 1 cm cube, 2 cm cube, etc. Okay, then you talk about the dependent variable, the thing that you are measuring. So you measure the rate of respiration by measuring the time taken for the bicarbonate indicator to change color. In some sense, your dependent variable, right, should be very similar to the experiment that you just did. Unfortunately, some of you, when you're writing this answer, you are writing things from perhaps your another experiment. You are talking about things like counting the number of bubbles, things like that lah, which don't make sense. I think you are thinking about maybe a catalyst enzyme, measuring the height of the foam and that kind of stuff. These are all these are things that can happen in other experiments, but you already did the experiments once. So kind of use the knowledge from this paper to help you to answer the question here. Alright, so out of these three, right, you will get 2 points between these three. But for the last point, you must have this statement, right, which is your reliability statement. So you need to repeat the experiment 2 more times and plot the average results on a graph. When you increase the number of times that you do the experiment, you are increasing the reliability of the experiment. And when you plot the result on a graph, then you can finally see the effects of the temperature on the rate of respiration in the yeast, because that's what the question wants you to do. Investigate the effect. Right? So you need to see how it's affecting. Alright, those are the 3 marks. Okay, now we talk about the drawing question. So over here, you can see one example of the drawing. I think basic rules about drawing, I think most of you got it already. I think some of you get very, very good drawings. Your drawing must be at least 75% of the space given and the proportions are right. Now, a few of you, you drew, how to say, like vertically, right, instead of horizontally. So you think to yourself, which one makes more sense? You have a very long object, right, and is going from this way to this way. You can turn your seat, right? You can and just face it in the correct orientation. So please try to draw it from left to right if possible, right? So you can fill up that whole space. If you draw from the bottom to the top, can also, right? I won't say that it's wrong, but then that leads to another problem which I'll talk about later, which is measuring the length wrongly. Okay, so make sure that your drawing is 75% of the space provided, the proportions are right. That means the seat is not too mega big or too mega small, right? And then the pericarp, right, that layer, you can see that pericarp layer also, although I didn't ask you to label it. Make sure that your drawing is neat and clear, no broken or fuzzy lines. Please do not shade in your drawing, right? Do not add unnecessary details that we do not need. Just try to keep it as simple and as clean as you can, whilst leaving the relevant details there. And lastly, I'm very disappointed in this part, right? Labeling the seat. Some of you didn't read the question again, right, and lost a mark just here. You didn't label the seat, even though I'm sure that everybody know what a seat is. So the key thing about doing your practical is you need to read very carefully and fulfill the instructions. Think of it like you are doing a cooking test, right? Yeah, being tested on cooking. If you miss one step in cooking, right, your whole recipe is a failure, right? And why do you want that to happen to you? I don't think that's something that you want. I know you're under stress, so I can understand, but these kind of mistakes are really unnecessary mistakes, right? So please read the question carefully and label the seat. Next thing, all right, draw a line and record the length of your drawing. Some of you didn't draw a line. Okay, this time close one eye. Make sure that you follow the instructions that's provided to you in the paper. Then you use a ruler to measure the length of the specimen to the nearest millimeter. Okay, again, some of you get a bit confused. What's the difference between length and width and height? Just measure the longest thing. All right, so from the bottom all the way to the top, that is the length of this thing. Okay, then you record down in millimeter, and then after that you measure your drawing first, then you measure the actual specimen. Okay, so for the actual specimen, it should be between 70 to 100 mm approximately. Of course, if your one is really very, very long, right, then so be it lah. I mean, I went to measure most of them first, and they're all between 70 to 100. Okay, so it's around that. Then for your drawing should always try to be bigger than your actual specimen. So for example, if your specimen is about 100 mm, your drawing should at least be 120 mm, which is 12 cm lah, right? It will be 12 cm. So why are you trying to draw it bigger? Because you are magnifying something. You are trying to draw a image, right? The drawing bigger than the actual object. Okay, so let's talk about the correct magnification calculations. For example, right? You ECF your pot is 110 mm or 11 cm, right? The drawing, right? And then the actual pot is only 80, right? So what you do now is you can just divide them, right? There's no fancy formula here. Some of you went to multiply by 10,000 1,000 there's no need to do that at all. I think you are confusing some other kind of math equation in there already, so don't get so confused. So you get some number, let's say 1.7, 1.375, right? You know that this is not to 1 dp, and the standard, right, for magnification is 1 dpx. So you just take these numbers, you just round it up to 1 dp, 1.4x. Then that's your 1 mark. Not very difficult, but I think some of you made it more difficult than you really need to do. Okay, let's wrap it up. Okay, so a man was diagnosed to be at risk of coronary heart disease. He was advised to go on a low starch and low sugar diet. He wants to know if he can continue to consume this snow pea. Use the reagents provided to carry out sufficient tests on the seed of the snow pea. You may grind the peas using a pestle and mortar. So the mistake I saw that some of you make is you forgot to grind this pea. If you forget to grind it, there's this like kind of protective layer around the pea, the seed, which will actually prevent you from doing the experiment properly. So for some of you, you may realize that if you don't crush it properly, it will actually not react well. Okay, so these are the observations that you should be seeing for the Benedict solution, which is for your reducing sugar, right? You should be observing a green or an orange precipitate that will be formed. Again, I'm also quite sad here because some of you didn't write the word precipitate. In fact, most of you didn't write the word precipitate, right? And I emphasize this many times, right, during our practice sessions, that this Benedict's test is not forming an orange solution, right? It doesn't form any orange solution. It forms this precipitate. You recall what's a precipitate? A precipitate is an insoluble substance that's formed within the solution. So you got to be precise here. We are doing science. We are not doing some kind of literature. We need to be precise in our language. So if there's green, there'll be a trace amount of reducing sugar. If it's orange, there's moderate amount of sugar. Okay. For this round, I give a bit of BLD. I think some of you wrote big red. Okay, fine. At least you write precipitate. I'll still give you the mark for that. Okay. And you wrote the correct deduction. So I give you the benefit of doubt. Maybe somehow you crush a lot of seeds and then you got a lot of reducing sugar. Fine, so be it. But if you wrote simply green color was seen, observed, right, or even worse, solution remains blue, right, then that's wrong. Okay, for iodine solution, right, or the iodine test, right, the iodine solution would turn blue-black and therefore starch is present. Okay, some of you again made the mistake. You didn't crush the pea properly, and so you didn't observe the blue-black coloration. All right, so that is our paper 5. Right, I'll pause the video here. You can watch the next video on paper 4 and then subsequently on paper 1 later. Okay.